Okay, so today I want to first make sure everybody's on the same page with the structure of the class, where to find stuff, how to turn stuff in. And then I want to answer questions, any questions anyone has, and then I have a few problems for us to do to make sure that the stuff in the lectures so far is making sense. So first of all, does anybody know they're having trouble finding lecture videos, finding the assigned problems, turning in the assigned problems, that kind of stuff? Let me just go to D2L and so here's how it's going to always be. When I assign lecture videos and problems to do, I'm always going to put it in the announcements section. I'll put links to the videos, and these videos are where all the content in this class is going to be. You know, this is just going to be, these class meetings are going to be first where tests and quizzes are going to be, and then second, they're just going to be answering questions and working on problems and making sure that everybody's making sense out of the problems I'm assigning. So when I assign lecture videos, they're going to be here. And underneath that, it'll give an assignment, you know, some numbers to do from some set of problems. So right now, the ones that you've been assigned are units and scientific notation. So if you go to content, go to problems for daily assignments, go to the units and scientific notation, and there are those 9 problems. Okay. And then to turn them in, take a picture of it or scan it and submit the file to assessments, assignments. Right now, there's only one spot for a daily assignment because that's the only one I've done so far. I'll be doing overall about 2 a week, but right now there's only been 1 so far. Okay, so that makes sense to everybody? 52 people at least have made sense out of it all. So, yeah. Okay, what does it do? Do I know that? Really? Oh, well, that's nice. If you ever, so I do have deadlines written up there, but they're not enforced on that. If you ever have a thing where, you know, you meant to turn something in and then realize you didn't, just let me know, send me an email, send me the file or submit it and send me an email saying that happened, and I'd be happy to give you credit for it. Okay. So don't worry about like deadlines or anything. Those deadlines, I mentioned this before, but really those deadlines are just to try to keep you on track so you don't get behind. It's not really like it has to be in by this time to get credit for it. Okay, now on the conversions and units and scientific notation, anybody have any questions on the assignment that you couldn't figure out that you'd like me to go through? Yeah. 8? Okay, great. I mean, not great that you had a problem with it, but. Let's see. Okay, so 15.5 kilometers, and it just gives us all these different things to convert for. Great, 15.5 kilometers. And this uses the prefix thing, so that can get a little confusing. Okay, so number 8. So we're going to start with 15.5 kilometers. And watch this. Okay, maybe that wasn't so great. There it is. Did I delete? What the hell? I'll deal with that later. So we start with 15.5 kilometers. And when you start with, when you start with a prefix, like in this case, the prefix is kilo, right? It means 10 to the third. I'm gonna just put that into my number, and that'll convert us from kilometers to meters on its own right away. So I'm gonna think of this as 15.5. I'm gonna replace kilo with times 10 to the third. And that's gonna be my starting point. Okay, so that's actually the answer to A by itself, although this isn't really in scientific notation yet because we have more than one leading digit before the decimal. So I guess the last thing I have to do is change this to 1.55 times 10 to the third meters. And now from part A, we have this this value that doesn't have a prefix, and we're trying to go to one that has a prefix. Yep.
Would that be 1.5
Yes, it would. Yeah, you can't just move the decimal over. Sorry about that. So the way I think about this is if you make this number smaller by moving the decimal point, you have to make this one bigger, So Okay, so now for part B, we're going to go to something that has from something without a prefix to something with a prefix. So we know that milli means times 10 to the minus third. Okay, so we can think of 1 millimeter as equal to 1 times 10 to the minus third meters. Okay, and then we can use that as a conversion factor. So that means that 1 millimeter over 1 times 10 to the minus third meters is equal to 1 times 10 to the minus third meters over 1 millimeter. Okay. And so now we can just do like a regular conversion. So 1.55 times 10 to the fourth meters. Our unwanted units are meters. So that means for our conversion factor, we want meters in the denominator. So I'm going to multiply this by 1 millimeter over 1 times 10 to the minus third meters. The meters cancel out, and you get 1.55 times 10 to the seventh millimeters. Yep.
So, for whatever reason I kept it, or I just had 10 to 6.
Mm-hmm.
Yeah, then I just had 15.5.
15.5 times 10 to the sixth is the same thing, but just know how to, and this one didn't specifically say scientific notation, but I guess it's a good habit to either don't do half scientific notation. Like if you're going to use the exponent notation, just put it in scientific notation.
I noticed that when I looked at
Yeah.
some of my ultimate is correct, but I'm just there was like a rhyme or reason why.
Yeah.
Is it better to have it that way than to have it 15.5?
Yes. Because
That's a smaller number.
you just always want one leading digit in front of the decimal point. Any other questions on that one? Okay, and then part C, now we want to go to microns. So this is pretty similar to part B. It's just a different unit with a prefix. So 1 micron, looks like micrometer, is 1 times 10 to the minus 6 meters. So your conversion factors are 1 micron over 1 times 10 to the minus 6 meters, or 1 times 10 to the minus 6 meters over 1 micron. And I'm going to just start with meters again. So 1.55 times 10 to the fourth meters. Again, our unwanted units are the meters, so I want those in the denominator. So I'm multiplying times 1 micron over 1 times 10 to the minus 6 meters. The meters cancel, and you get 1.55 times 10 to the 10th microns. And then miles, we're going to use 1 mile is equal to 1609.344. If anyone's PSEO and is still is planning to run track this spring for the high school. I think every time you run the mile, you should just run an extra 9.344 meters and just tell your coach you're not quitting early like everyone else. Okay. Will you do that for me? Okay, 1.55 times 10 to the fourth meters. And then the conversion factor, we want meters in the denominator again, so I'm going to do 1 mile over 1609.344 meters. And I don't have that solution with me, but it's a little less than 10, I guess. Does someone have a calculator in front of? Could someone punch that out? Okay, 9.631 miles. And if you were in chemistry, they'd be furious about the significant figures, but here we don't care. And all of these are just sort of more practice with the same kind of thing, but so now we're going to megameters. Mega means times 10 to the sixth. So 1 megameter is 1 times 10 to the sixth meters. And so 1.55 times 10 to the fourth meters. We'll multiply by 1 megameter over 1 times 10 to the sixth meters. If you divide 10 to the 4 by 10 to the sixth, the exponent rule says that that's 10 to the minus 2. So this is 1.55 times 10 to the minus 2 megameters. And then the last one is centimeters. So 1.55 times 10 to the 4 meters. A centimeter, centi means times 10 to the minus 2. So we have 1 times 10 to the minus 2 meters is equal to 1 centimeter. And you get 1.55 times 10 to the sixth centimeters. Any questions about any of those? So the thing with the prefixes is if you're starting with a value that has prefixes, like in this case we started with millimeters, I think it was, then just replace the milli with whatever it, replace that prefix with whatever it means. So that's what I did in part A. I just, instead of writing milli, I just put in the times, kilo, I guess. Instead of writing in kilo, I just replaced it with times 10 to the third. So that's if you're starting with something with a prefix. If you're trying to go to something with a prefix, then you have to do it as like a unit conversion, and just do your unit conversion like this way. Think of what that prefix means, do the equivalency between the thing with the prefix and the thing without, and then use that as your conversion factor. Okay. Any other problems anyone would like to see? Yeah. I think these are the only ones, and really I can't think of it coming up very often after this section is over. But if I ever, you don't have to memorize any of these, like if it's ever on a test or something, I'll just tell you what the prefix means. You just have to know how to use it in a conversion. Okay. I'll always give you any equations, any conversions, anything like that. So there's nothing you really have to memorize. Any other problems anyone would like to see? Okay, well, I have a few problems that I was thinking I'm just going to write them up on the board, and you can take a little time to work through it, make sure that all this stuff is making sense. Then I'll go through it so you can check your work, and that's just how we'll spend the rest of the class today. Okay. So the first one is start with 50 inches. And the first thing we want to do is convert this to meters. And we're going to use that 12 inches is equal to 1 foot. 12 inches is 1 foot. And 1 meter is 3.281 feet. Okay, so just take a few minutes, work through this, and then I'll do it, and then we'll go on to the next one, or the next part. Okay, so we have 50 inches. With the conversions we have here, we're going to have to go from inches to feet and then feet to meters. So 12 inches in the denominator, 1 foot in the numerator. And then we have to go feet to meters. So in the denominator, 3.281 feet. And in the numerator, 1 meter. And you get, I don't know, I didn't write it down. Can someone tell me what you get when you, so 50 divided by 12, and then divide that by 3.281? 1.267. And that's in meters. Okay. And now let's do the same one, but let's go to, so this time let's convert to millimeters. So remember that milli means times 10 to the minus third. And again, we'll use that 1 meter is equal to 3.281 feet. And put your answer in scientific notation. Okay, so we know that 1 meter is 3.281 feet. In order to go to the prefix, we're going to use the conversion. 1 millimeter is 1 times 10 to the minus third meters. So we're starting with, I suppose we could start with the meters there that we already did. 1.267 meters. And we want to cancel the meters, so in the denominator we have 1 times 10 to the minus third meters. In the numerator we have 1 millimeter. Those cancel. And you get 1.267 times 10 to the third millimeters. Yep.
Why do we do it like that and not 10 to the third millimeters is 1 meter?
That works too. I just like this because I like this way of thinking about it because there's a meaning for each one of those prefixes, and then it's like you don't have to think about, like, that mostly just from experience, or like that's a unit we've used. But when you get outside of units you've used a lot, you can just use that prefix and say it has a meaning. Its meaning is times 10 to the minus 6 or whatever. Plug it in, and it's just something that'll always work, But what you're saying will get the same answer, and that's you get full points doing that on a test or something. Any other questions about this? Okay, so let's go to one now where we have a combination of unit types. So let's start with 25 miles per hour. And let's convert to feet per second using that 1 mile is 1,760 yards. 1 yard is 3 feet. 60 seconds is 1 minute, and 60 minutes is 1 hour. So we're going to have to do it in, 4 steps. Okay, so go ahead and do that one. So we're starting out with 25 miles per hour. So I'll write that as 25 miles divided by hours. I'll do the miles first. So we're going to go 1,760 yards over 1 mile. That's because we want to cancel that mile. And then we'll go 3 feet over 1 yard. And so now if you cancel all the distance units, you have feet, so that's what we want. Now we just have to do the hours to seconds. So 1 hour, that is to go in the numerator, over 60 minutes. And then 1 minute over 60 seconds. And now the hours cancel, the minutes cancel, and you just multiply these 3 numbers, divide by 60 and 60, and what do you get for that? Okay, so 36.7 feet per second. Yeah, question? Oh. Anybody have any questions about that? Okay, let's do one that gets prefixes into this. So now let's say we want to convert this to kilometers per millisecond. And we want to do it in scientific notation. So we need to know that kilo means times 10 to the third. And milli means times 10 to the minus third. And then what else do we have? I guess we can use that 1 mile is 1609.344 meters, and 1 hour is 3,600 seconds. Okay, so see if you can work through that one. Those prefix ones are definitely the... So we're going to start with 25 miles per hour. So 25 miles over 1 hour. To go from miles to meters, we'll go 1609.344 meters over 1 mile. To go from hours to seconds, we'll go 1 hour over 3,600 seconds. Now to go from, so if you do the cancellations, wrong. You can see that we have units of meters per second now. So now we just have to go to kilometers and milliseconds. So to go to kilometers, we know that 1 kilometer is 1 times 10 to the third meters. And we want to cancel the meters. So we want the meters in the denominator. So 1 times 10 to the third meters is 1 kilometer. And so now our meters are canceled. And then the last thing we have to do is go from seconds to milliseconds. We know 1 millisecond is 1 times 10 to the minus third seconds. So 1 times 10 to the minus third seconds is equal to 1 millisecond. Cancel the seconds. And can someone divide this out for me?
It would be 6.94 times 10 to the negative 9.
6.94 times 10 to the negative 9. And that is in kilometers per millisecond. And it's a very small number, way, way, way less than 1, because you're talking, a kilometer is, more than half a mile, and a millisecond is a very tiny amount of time. And if you're going 25 miles an hour, you go a very small fraction of a half a mile in a 1,000th of a second, Any questions about that one? Okay, let's just do one more big finale, and then we'll leave early today. Okay, so let's say that you're starting with 100 PSI, so that's a pressure. And PSI stands for pounds per square inch. And we want to convert to, let's do kilonewtons per millimeter squared. And we're going to use that 1 pound is 4.448 newtons. And 12 inches is 1 foot. And 1 meter is 3.281 feet. And then these are the same two we used last time, but kilo is times 10 to the third. And milli is times 10 to the negative third. And again, give your answer in scientific notation. Okay, go ahead. Okay, so we'll start with 100 pounds over inches times inches. So first I'll go pounds to newtons. 1 pound in the denominator, 4.448 newtons in the numerator. Then I'll go one of these inches to meters. So 12 inches is 1 foot. 3.281 feet is 1 meter. And now I'll go meters to millimeters. 1 millimeter is 1 times 10 to the minus third meters, because that's what milli means. So 1 times 10 to the minus third meters is 1 millimeter. So now if we do this cancellation, meters, feet, and we've done one of those 2 inches. So we have to do all that again for the other inch. So 12 inches over 1 foot, 3.281 feet over 1 meter, 1 times 10 to the minus third meters over 1 millimeter. And we have the other inch. And I guess what I didn't do before, I converted to newtons, but not kilonewtons. So now I have to go newtons to kilonewtons. 1 kilonewton is 1 times 10 to the third newtons. Our newtons are in the numerator, so we need our 1 times 10 to the third newtons in the denominator, our 1 kilonewton in the numerator, and that cancels that. And the only units that are left are kilonewtons per millimeters times millimeters. And what do you get when you multiply all that out? Anybody?
43 times
6.89 times 10 to the minus fourth. To the minus fourth kilonewtons per millimeter squared. Any questions about that one? Okay, well, that's it for today. So let me know if you have any questions. I'll put up a new video, a new assignment today or tomorrow. Let me know if you have questions on that. And, oh, this is important actually. Labor Day is Monday, and I have a lab on Mondays, so we're not doing any labs next week for anybody, okay? So no lab. So I won't see you until next Wednesday in this class. Okay, bye.